Well, this problem has quite a bit of information in it. There's the labor required for making a table, as well as the hours of finished work. The same thing for chairs, and then they've got a grand total for each that they can't surpass. And when there's this much information, sometimes it's a good idea to go to the very last thing and see what they're asking about. And that is find the number of tables and the number of chairs. So I'm going to have T be the number of tables, and C will be the number of chairs that they can produce. Now, for each table, we're going to have to keep track of the labor and the finish work. And so the labor is 8 hours, the finish work is 2 hours. So for a table, that's for each table. So in total we would have 8 hours per table in labor and 2 hours per table in finish work coming from this. And now we need to do the same thing for each chair. So there is 2 hours of labor. So in the labor column, we've got 2 hours. In the finish work, this is labor row, finish row, we've got 1 hour for each chair. And when you add all of the labor together, it's supposed to be a maximum of 400 hours a day, less than or equal to 400. And when these are added together, it needs to be less than or equal to 120. And now we've got a system of linear inequalities, 2 variables. And so I need to be able to graph these. I'll need a table of values for each one. So over here on the side I can say, well, if I've got 8t plus 2c equal to 400, then I can make a little table of values. For example, if t was 0 tables, then solving for c is going to be 200. And if they made 0 chairs, then dividing both sides by 8 would result in 50 for the t tables. And now do the same type of thing with this. So 2t plus a c is equal to 120. And if t is equal to 0, then c, number of chairs, would be 120. And if the number of chairs were equal to 0, then dividing both sides by 2 would give us 60. So I'm going to graph this one in red, and I'll graph this one in black. So I've basically set it up as if this were the x variable and this were the y variable. So this is going to be the horizontal variable, the number of tables, and vertically is going to be the number of chairs. Also, we need to be graphing only in the first quadrant because negative tables or negative chairs don't make sense. So just graph it in this first quadrant. So with this one, I've got 0 for t and then 120. Let me try and draw this to scale a little bit. Let's see, the c goes up to 200. So in the middle would be 100. And then that means right about here would be 100 and here would be 50. Okay, so with this one, 0 and then up to 120. And then go over by 60 on the t-axis. Both of these have equals as a possibility, so I should be using solid lines. And again, this is supposed to be just in the first quadrant, so I just need to draw this part of it. And now for the other line, which would be at 0 to 100. That's 0 for T, 200 for C, so that's up there. And then 50 and 0. And then draw that line. And now we need to go back to the inequalities and see which region is going to make this true. With these being less than or equal, most likely the shading is going to go below. And so if it has to be below each of them, that would be this region in here. Well, I can test that by using something that's below them and see if it works. Like, for example, 0, 0. And if I test 0, 0, this one is going to be 8 times 0 plus 2 times 0. Is it less than or equal to 400? And of course 0 is less than or equal to 400, so that one's true. And likewise, if you test the second one, the result is going to be the same. It's going to be 2 times 0 plus 1 times 0. Is that smaller than 120? Yes. And so the shading needs to go below both of these. So it would be below the red line as well as below the black line. So it's going to be that region in there. One other thing that we should point out is right here is where they're crossing, and that is important because that means that this tiny area right here is not shaded. So we should also find out where is that point. So we've got this system of equations that we would need to solve. We've got 8t plus 2c is equal to 400, and then 2t plus c is equal to 120. And if I multiply the bottom equation by a -2, then I would have -2c, which would cancel that, so use the elimination method. In here with the t's, it's going to be 8t minus 4t is 4t. And then here it's going to be, when you multiply this by -2, it's going to be -240. So we've got 400 minus 240. So we've got 400 minus 240 is 160. And then divide both sides, and t is equal to 40. And then substitute that back into one of the original equations, like this one right here. And I would say 2 times 40 plus c is equal to a 120. So this is 80. Subtract 80 from both sides, and it leaves 40. Oh, nicely balanced. 40, 40. So this is at 40 for tables and 40 for chairs. And now we have the whole region defined.